Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video we're going to be looking at differentiating exponential functions. By the end of this lesson, you'll be able to differentiate exponential functions with base e and differentiate exponential functions with other bases. This is for the Year 12 Mathematics Advanced course. Let's have a look at the first part of this lesson, base e. So in your formula sheet, we've got this formula here. If we have the function y equals e to the f of x, when we differentiate that, we'll get f dash of x e to the f of x. So what that means is, here we've got this, we're going to write exactly the same thing, and then in front of that, we're going to write the derivative of the power. Alright, so let's have a look at some examples. Differentiate y is equal to e to the power of 7x. So here we've got e to the power of f of x. So when we differentiate that, y dash, we're going to write exactly the same thing, e to the power of 7x. And then we need to differentiate this with respect to x, which is just 7, and we put that at the front. Alright, question B. F dash of x is equal to, here's our e to the power of f of x. We're going to write exactly the same thing. And then we're going to differentiate this power. When we differentiate that, we get 3. We're going to bring it out to the front. But because we already have that 5 at the front, we're going to multiply them together. 5 times 3 is 15. Question C. Here's my e to the power of f of x. So y dash is equal to, I'm going to write down exactly the same thing, e to the power of f of x. And then I'm going to differentiate the power. That's going to give me minus 1. And I'm going to times that by the number out front. So minus 2 times minus 1 is positive 2. Alright, question D. What I'm going to do here is I'm going to actually rewrite this question as f of x is equal to 3 over 2 e to the power of 4x squared minus 1. That way I can separate it. This is my f of x and this is my coefficient. So we've got f dash of x. We're going to differentiate now. I'm going to rewrite this as exactly what it is, e to the power of 4x squared minus 1. And then I'm going to differentiate this and multiply it by whatever's in front. So when we differentiate this, we'll get 8x. So we have 3 over 2 times 8x. That's going to give me 24 over 2, which is 12x. All right, question E. Y is equal to x squared e to the x. Now here we've got this. We also have this. They are both in terms of x, which means we actually need to use the product rule when we differentiate. So the product rule we know is vu dash minus uv dash, plus uv dash. U is the first term, v is the second term. But when we differentiate u, we get 2x. And when we differentiate v, we get e to the power of x. So, what do we get when we differentiate this whole thing? v u dash is these two times together. So that gives us 2x e to the power of x plus uv dash, these two multiplied together, is x squared e to the power of x. I'm going to factorize this just to simplify it. I'm going to bring out an x e to the power of x, leaving me with 2 plus x in brackets. Right, question F. Here we can see that the fraction both the numerator and the denominator are in terms of x. So again, this time we need to use the quotient rule. Now the quotient rule says, oh, I'm going to use f dash of x, because this is f of x, is vu dash minus uv dash over v squared. So u is the top, e to the power x plus 1, and v is the denominator, 2x. What do we get when we differentiate u? We just get e to the power x. And what do we get when we differentiate v? We get 2. So vu dash, these two multiply together, which is 2x e to the power x, minus these two multiply together, 2 lots of e to the x plus 1, all over v squared. Alright, let's expand and simplify. So we've got 2x e to the x minus 2e to the x minus 2, all over 4x squared. I can see that every single term here is divisible by 2. I can divide this by 2, this by 2, and that by 2, as well as this. So I'm just going to divide out the 2, leaving me with x e to the x minus e to the x minus 1, all over 2x squared. Alright, question G. Here we've got y equals e to the x plus x all to the power 5. So it looks like we need to use the chain rule. So y dash, I'm going to bring down the power. I'm going to write down whatever's in the bracket exactly as it is. Reduce the power by 1. And then I'm going to multiply this by the derivative of what's in the brackets. When we differentiate this, we get e to the power of x plus 1. And that's it. For question H, again, we're going to do the same thing. Because we've got something to the power, we need to use the chain rule. So I'm going to bring down the power, write down exactly what's inside the brackets, reduce the power by 1, and then I'm going to multiply that by the derivative of what's in the brackets. Well, when we differentiate this, we're going to get, let's have a look at this part, because the 3 will disappear. I'm going to write e to the 2x exactly as it is, differentiate this and bring it to the front, leaving me with 2. Let's tidy this up. 5 times 2 is 10. So we've got 10 e to the 2x times 3 plus e to the 2x lots to the power 4. Alright, what about other bases? Bases that aren't e. This is the second formula in our formula sheet that we need to know how to use. These questions aren't as common, but it's always important to know how to use this formula. So here, if we've got y equals a to the power of f of x, not e, so some number to the power of f of x, then when we differentiate it, dy dx will be ln of a, ln of the base, times f dash of x times a to the power of f of x. So you'll notice here that this is exactly the same as that, but we've got 2 additional things that we need to add to the front. ln of the base and the derivative of the power. So let's have a look at this example. We have y is equal to 5 to the power of 3x. We notice that the base is not e. So when we look at this formula here, we know dy dx. I'm going to write down exactly what it is. Okay, so here, write down exactly what it is. 5 to the power of 3x. In front of that, I'm going to have ln of a, so ln of 5, times f dash of x. So here's my f of x. When we differentiate that, we get 3. Now I'm going to tidy this up. I'm going to bring the 3 out to the front. I'm going to have 3 ln of 5 times 5 to the power 3x. Okay. Please do not mix this up and say, oh, 3 times 5 is 15. Okay, we can't just do that. That does not work. Okay, question B. Y equals 3 to the power 5x plus 2. So when we differentiate that, we're going to have exactly as what it is. We're going to have ln of the base. And we're also going to multiply it by the derivative of the power. So when we differentiate this, we just get 5. So bring that 5 out to the front. That's going to give us 5 ln of 3 times 3 to the power 5x plus 2. Okay. Do not multiply the 5 and 3. Do not multiply these ones either. Okay, the 5 goes out to the front. Alright, 2 more. F of x is equal to 2 to the power of 1 minus 7x cubed. So we want to differentiate this. I'm going to write down exactly as it is. We're going to have ln of the base. And we're also going to multiply it by the derivative of the power, which is minus 21x squared. So I'm going to tidy this up. I'll put the minus 21x squared at the front. Ln of 2 times 2 to the power of 1 minus 7x cubed. Last one. F dash of x. Write it exactly as is. Times it by ln of the base. Times it by the derivative of what's in the power, which is 22x minus 5. So I'm happy for you to leave it as that. You can bring out the 22x minus 5 to the front if you want, but I'm just going to leave it as that. Okay. So I hope you found this video useful. Hopefully now you know how to differentiate exponential functions with base e, as well as other exponential functions with different bases. If you found this video helpful, please give it a like and subscribe, and I'll see you in the next video. Peace.